Wah! There we go. Excellent. Hello, everybody. I see you, and you see me, and we gotta do some stuff. So, for those of you who are in the Discord, you've already gotten a little spoiled to see what I'm about to show today. But, I am going to do a little bit of, words and things and sentences and maybe some punctuation if I'm feeling fancy. I'm going to show you what the code looks like for this. And I'm going to touch over what's integrated, for the Protogen screen. After I'm done going through stuff and things of that nature, then we're going to pivot, and we're going to do a little bit of live development this evening. I got my hands on a little fan, and I don't want to wait until next stream to play with it, so I figured we'll just play with it live. I have a decent idea of what we're about to do, but I don't have any of the syntax, and I have really no notes other than just the base knowledge I have from programming, what I've done up until this point. So we're going to toy with for that for a little bit. I'm going to show you how absolutely ridiculous this thing is. I accidentally chewed through a bit of a tissue with it because it got stuck in the intake. I did mention that there was going to be a fan menu in this project, so I'm hoping I can incorporate this little dude into the project, because I'm going to tell you something right now. This thing pushes air. And you'll see what I mean, because it's ridiculous. Also, welcome in, Porsche. Hello. Oh, ads. Ads are rude. They do that. I need something to tell me when there's ads. I have nothing on any of my dashboards for that. I don't know how hard that'll be to add. Well, we're not doing it right now, but I would appreciate having the context. Welcome back. You didn't miss much, Porsche. The TLDR version is I'm gonna show you the screen. We're gonna play with a fan and hopefully not burn up anything this evening. That's where we be. So yeah. Howdy in Pine. Hello. So, without further ado, we're just gonna jump into it. So, all right, excellent. Okay, so as most of you know, I'm working on building a Protogen Head. For those of you who don't know what I'm talking about, well, we're going to talk about it. That's where we're going. Now you're going to notice something that's a little unusual for me. I don't have the boards connected because I'm going to show you the demo without it connected to the computer. The whole point is that for this to operate independently and not be connected to the serial monitor. So this is the perfect test to make sure that when power only is supplied and we can't see anything in the serial monitor, like we are in the case of right now, that it works as intended. So I'm only going to show you the sketch for the screen, the board that's going to be connected to the displays that are going to be visible to the person wearing the head, aka me, and the two screens that make up the outside of the face that everybody else will see. So that's why this project is lovingly named Screen Main / Data Peer. This is the one that's going to get all the sensor data. Now, I had made, I don't want to call it an error, but when actually, I'm going to pivot back here for a minute. Get closer. When I initially chose the menu system that I built this on, I chose this particular option because it straight up said in the documentation that it supported controllers. Like the kind of controllers you have, that I'm going to show you. And I'm like, great, that's perfect. As I started to work on programming it, I had discovered something. I may have a controller, but it's not directly connected, which means the method you use for declaring a controller isn't going to work in my case. which left me looking very dead. And I thought to myself, okay, there can't be the case of I've thoroughly screwed myself, right? Right? I hope. No, please. Like, I don't want to be here, okay? This is not where we wanted to be. And I'm like, it can't possibly be that bad, right? To like figure this out. The reality was, no, it actually wasn't that bad at all. But when the controller is remote, right? It's remote. It's still going to be, wired and powered. But my point is that the controller itself is not physically connected to the board that will be running the faces. That means it's not directly connected, so I have no pin definitions. All I have is the data that I have in the variables. So think of it like your TV, right? You have the buttons on the all right, well, let's go back to a television from the 90s, right? I can't say a current TV. They don't put damn buttons on anything anymore. Picture an old school television, right? It had a power button, and it had volume up and down, and channel up and down, right? And you could click those buttons on the side of your television and it would do the respective thing. You could turn the TV on or off. You could make the channel go up or down, right? Or you could grab the remote control, sit on your couch, and click the respective buttons on that remote and control the same thing, right? The concept of a remote control isn't hard, but that's essentially what I did here. I'm trying to do the same function without it physically being connected. Oh my god, Pine, I miss buttons so damn bad. That's part of the reason why my project is a physical controller that I can hold with my hands. I don't want to have to navigate a touchscreen. If my vision is impaired because I'm wearing a suit head, I don't want to have to try to look down through a gap. I need to already be looking where I'm walking. I need to be able to modify and manipulate this menu without ever having to look down. And that same theory about technology from the 90s is where this is inspired from, because everything during that era had tactile buttons, switches, dials, and you could get into a car and you could, without even looking down, reach for the section of the temperature control and set it to hot or cold. You didn't even need to look because the dials were exactly where you needed them. Oh my God, yes, Porsche, exactly, the muscle memory of it all. You don't ever have to look down. Well, now with a touchscreen, that's the only thing you can do is look down. Don't get me wrong, I love touchscreens and I do enjoy the layout of my phone, but the reality is a touchscreen should not be the end-all, be-all of a menu, okay? There is a time and place for there to be physical buttons on something. And I want to give you a perfect example of where touchscreen is not the right answer, okay? Because the monitor that I'm looking at over here, when I pivot and I'm showing you the laptop that you guys see, that's a touchscreen monitor. And you want to know what the controls are for turning it on, off, and changing the menu options? They're touch. You know what happens when you accidentally bump the lower corner of a touchscreen monitor? You turn it off, or you open the menu. Maybe you change the brightness, potentially invert the picture. That's why that menu is locked permanently on that display. I have a label on it to indicate how to remind myself how to unlock it if I need to change a menu setting. But I will regularly pop up that menu, indicating to me that I bumped one of the touch controls, and instead of the monitor shutting itself off like a goober, it just pops up that little brief message. So, that being out of the way, I'm now working with a menu and I have data. Now let me show you, let me get into it. But that I quickly realized was going to be an issue, right? So I'm going to just breeze over what we've covered already. I've covered a good majority of this in the VOD. So right now, the expressions that I have in the menu, which are these right here: idle, happy, sad, angry, and shocked. Those are really just placeholders for me for right now, because I don't know what expressions I'm going to be making. I haven't figured out just yet the big screens, the way to make the face. I have some example code from another Protogen creator that we're going to be incorporating. And they made it freely available on their GitHub. It's free for use for personal, commercial. The only thing on the license about it is limited liability. So yes, I'm going to tell you about it. I'm going to name drop them. There is going to be references back to their original project inside of this one. I will be releasing this once I have it in a close enough state of me considering it quote unquote done. I truly don't think I'm ever going to be really done working on the proto, but getting the after the initial build, then the code will be public. That's my plan for this. And then of course, as I add and change and I tinker as I do, then I'll make updates to that as I move forward. But the for right now, the menu options you see are likely going to change, but it's really more of a proof of concept to give me the framework. Because if you have the frame of a house, well then you can put the tub in, you could put the counter in, you could run the pipes and the wire. You know what you can't do? You can't do any of that if it's dirt. If you're standing in a dirt field, you can't do any of that, right? Same thing here. You build yourself a framework and then you continue to work off of it and make it better. Add more things to it, manipulate it, the whole kind of thing, right? So we got that going on. Yeah, so we've got the definitions for our menu. We've seen these before. The menu is only 2 levels deep. We've seen that before. But what I gotta show you is how we actually modify which menu option we're looking at. Because, as I had shown in a previous example when the board was connected, I would type in the serial monitor to go through the menu options. I would use the plus symbol to go down, the minus symbol to go up, and then to go into a menu to confirm, that was the star key, and to go back a level or escape, I would hit the /. And that gave me the 4 directions of the menu. Now I'm using controller data, so now we're trying to, mesh those 2 together to make it happen. But since I can't directly read the information off of the controller, because it's not directly connected, you're going to get to see that. I have that over here on the bench. I then had to figure out how to navigate without doing that. So then my first thought process was, okay, well, there's this line of code called serial write. And serial write is essentially just pressing buttons on your behalf. And I thought, okay, piece of cake, I'll just do that. That'll work. No, it didn't. It didn't work. And I'm gonna be completely honest with you. I thought I had that in the bag. And then I dug further into the documentation and thinking, okay, well, everybody says, including those who have used this in their project, that this menu is incredibly flexible. So you should be able to use other data to issue commands to move about it. That's all I need to do. I already know what values in my head were going to make the menu go up, down, forwards, backwards, all of that, right? Wasn't worried about any of that. So we're going to get past all of the setup, pre-shared keys. I didn't change any of that yet because this isn't production code yet. This is all the stuff to make the initial connection to the other board. I can tell you that probably for the first iteration of the Proto Head, the Proto Head's probably going to forget its peer every single time unless I can figure out how to store the previous peer when the power is lost. So essentially it's just going to power up and treat it like it's a new device every single time, but they'll find each other. There won't be anything to do to interact. And since the idea is that the pre-shared key and the local key are going to be unique to each protogen that reuses this project, no one should accidentally pair to the wrong person, assuming that they reboot in the same social space. Because again, I'm writing this to make it public when I'm done with it. For anybody else who wants to reuse it and take on this madness, such as myself. So we can get past all that. There's a whole bunch of code here. Okay, excellent. All right, now we're to the area I need to get to. So in the space of a controller, right? A controller uses, just for the analog stick, the thing you move around with your thumb, it uses 2 coordinates. It has a Y value, which is up and down, and an X value, which is left and right. For those of you who have spent time dabbling in 3D printing, you'll know that there's also a third option, which is the Z axis, which is the other movement option, which is left and right. Actually, no, technically, X, see, see in a three-dimensional space. Yeah. See, in 3D, X is forwards, backwards, Z is left, right, and Y is up, down. But in this example, we're using a controller that only has two axes. So X is left and right, and Y is up and down. There is no Z. So essentially it takes the same place. Honestly, that's easier to visualize when you're looking at an actual 3D printer. But since this menu only requires for me to go up or down, and then we use two of the other keys to confirm to go into or out of the menu, I don't need the X-axis. At no point right now do I need to be able to do anything with the left or right. So this code that you're looking at has no reference to the X-axis because we're not using it. I originally wrote this to bring over all of the data from the sensor so that as I was figuring out what we needed to do to actually make it useful, well, then we already had everything to our disposal. It doesn't hurt anything to send over all the information because then we have it and then we could just manipulate it as we see fit. So to figure this out then, instead of doing serial write commands, there's actually a method that's a part of the library called do nav, which says in the menu, I want you to take this action. So joy Y from the Wii controller data, because it's a Wii nunchuck, is reading the value of up and down on the controller stick. So if the value is greater than 130, which means you are physically pushing up on the Y-axis, then we want to go up in the menu. And then if you are less than 126, then you want to go down in the menu because you're pushing down. Idle is in the center of the controller, and idle is at 128 on my specific controller. I believe it's supposed to be 127 over 127, but mine is 127 over 128, which means the X, when you're not pushing left or right, just at steady reads 127.
Beep beep boop boop hard reset the Proot kappa.
Oh, that's rude. Don't you reset me. What are you doing? You come up in here and you reset the toaster. I'm in the middle of ranting. That's just rude. How you doing, Thunder? Ah, my word. So we have what we want to do when we go in the appropriate direction. Now this feels a little backwards, I'm not gonna lie to you, because the way this is written feels kind of backwards. I'm pushing up to go down, and I'm pushing down to come up, but when you see it in action, it's not inverted, but it reads inverted when you're looking at the code. I'm doing good, and I honestly cannot be in a better place right now. I'm having a good time. We're making progress in the toasty bits. That's this crazy project. Oddly enough, yes. Now, funny enough, if you wanted this to be like a yoke on aircraft, then you could have just left it where up is up and down is down, and then it would be flight sim controls. But I reversed the commands so that up was up and down is down. But the code is written backwards because of the values. And the only reason that's the case is because when you're reading all the values between the top and bottom, it's technically backwards, which is why it looks backwards. But that's okay. Just woke up and it's not even 2 a.m. Oh, good lord. That's madness. Yeah, but yeah, so any of you who've used the flight sims before, that's literally what we're doing. We're just basically canceling that out. And if I really wanted this to be flexible, I could always write, like a a menu of just settings that you can modify if you would prefer it to be backwards, or you could modify the code. I'm not looking to make this more difficult than it needs to be. Right now, I want to just get the base together, see what kind of space I have left after it's done putting it together, and then maybe we'll add some more stuff later. I don't know. We'll see. I just want to keep pushing forward until we get where we need to be. And then we have our buttons to confirm, which was the C button, which is our enter. And then the Z button is what we're using to go back in the menu, which is our escape command. Never used a gaming flight sim, but I did fly a proper MiG military training simulator. Thunder, that's infinitely better. That sounds like a good time. Yes, we are here. We are here to do the thing. War Thunder for me. That sounds about right. For me, that had to be Grand Theft Auto 5. The helicopter absolutely was the one that got me. I had a copy of Microsoft Flight Simulator back in the era of Windows XP, but it took up too many disks, so we couldn't install it on the computer. So we returned the game because it took up too much space. I excel at flying. I absolutely don't do the landing well. Yes, well, everybody can fly. There's the rare few that can land. Everybody else crashes. I flew on a lot of bricks. But yeah, this is all I needed to add to allow us to take the information from the controller and then use it to navigate the menu. I made one small change on the controller side, and that was because it's the same thing on this side, so I could just show you here, is this delay on how often it sends ESP Now messages, which is the sensor data. I lowered the value to make it send faster because this was modifying the whole loop. So you were noticing visible input delay from moving the stick to seeing the option update on the menu. And frankly, nobody likes slow menus, myself included. So I fired that up and modified that. To get is something that we could, not get frustrated over. But yeah, so as far as the code goes, that's all I'm showing you from the code side. I'm going to now show you the live demo of the boards themselves in action. I forgot how to zoom out the camera. Hold on, let me grab my remote. No, are we gonna be a problem child? There we go. That's better. All right, let's see here. I see microphone activity. Haven't messed with proper flight sims. Have done a few ground runs in an aircraft though. Basically just system engine checks. Oh, that's cool. All right, let me see here. I know normally it helps when I turn on the overhead, so I'm gonna do that. Okay, so normally you would see the boards connected to the laptop. That's not the case. So these would be our normal wires, and I'm setting them aside. These are not being plugged into the laptop. So what we have is we have the microcontroller that's going to end up in the head, and then this is our display, and it's connected via an I2C connector, this little guy right here. So when this is properly installed, and this connector is not just sitting in a breadboard, that's where the screen's going to be connected. And the other microcontroller is this one, which is using the same I2C connector to this breakout board that was made by Adafruit, which then allows us to move and interact with the controller. So with no physical connection between the two, I'm going to supply power, and then we're going to use this to modify the menu that is here. So what we're going to do is I have some cables here that are hooked up to one of those USB power splitters. So these just supply power, and the
the brick is off camera, but as you can see, no physical connection over here, which is what matters. So I'm going to plug this one into power. I say that as I spin it around 4 times. It's going to fire this up. And then the board, right now, we are going to see nothing on this display until I supply power to the second microcontroller and they both boot and find each other. Because right now, the code on this one is paused until it finds its partner. I don't know if it's going to stay like that in the production code. I haven't changed it yet because this was the example that finally worked. And I'm not scared to change it, but I need a better understanding of how to do it a different way, so that I really want it so that you could just pair them once and then they just turn on and always know that the other partner is there. But I haven't quite gotten that down yet. So I'm going to worry less about that, and we're just going to keep pushing forward. Now that this has got power, our screen came on. And then I'm going to pick this up so that we can see it a little better. So I'm going to carefully hold this, and I'm going to bring that up here so that we can see it. And then from this, I'm going to press to go down, confirm to go into the menu, and then down and confirm. I've set the fan speed to 69% power. Now, if I would like to turn off the display, I can escape one more level back, because there is no further back menu. So when you have reached the root menu and you can go no further back, telling the menu to go one more back shuts it off. So to turn it back on, I just hit it a second time and the menu comes back. Then from there, I could toggle up, and then we can hit the C to go back into the menu, and I can change my expression to shocked and confirm it. And just like that, you've got proof of concept. I have a working controller that is updating this menu, and then this menu is keeping track of which object I'm selecting, which we're going to use that logic that is stored in this menu to modify the faces we're going to have externally facing that everybody's going to be able to see. So that is the proof of concept of the menu, which, to be honest, the way I visualized it and the way it works is actually pretty close to what I was kind of hoping it was going to look like. So I'm pretty content about that. Whoops, I hit the down button. Nice. Very good. And then I set this aside. Now, something I do want to note, hang on, I gotta grab it, is that the, I did buy this kit for putting connector ends on. Show you what I'm talking about here. Come on, I need a loose wire. So these, right? These little dudes have these little black connectors on them. And I had purchased a crimping tool that allows you to add the ends onto a cable of your choosing. Problem is, I don't quite understand how the tool works. I had to do a little bit more of a skill check, because this is very much a skill issue, because all the ends I tried to put on ended up not fitting correctly into the connector, so you're gonna get to see that because I screwed up the fan I was working on last night. But thankfully, I could still show you so far what we've got in that regard. Because who doesn't love tinkering when it's late at night? I know I enjoy myself to doodle around in the menus while I'm, messing around with wiring to, some flavor of the dinosaur? What's a dinosaur? Oh, the crimper? You're calling this a dinosaur? I mean, all right, I guess you kind of got me there. It does very much have dinosaur-like teeth. So yeah, we're gonna, I'm gonna need to better understand how that works. But that aside, I want to show you the fan. So I'm going to scoot, because right now, before we even look at the code, I want to show you how ridiculous this thing is. So I'm going to bring over my helping hand, right here. And then I'm going to bring this into view. Okay, so before I clip anything, this is the fan. It's got a propeller. On this side, air goes in here, and it's shot out through the back, through the crevices back here. There's 3 wires. We've got positive, negative, and then the pulse width modulation, or the PWM pin. Now, I was doing a ton of research last night, and I'm gonna be completely honest with you. It's surprising to find a fan of this size and the caliber of how quickly it can move air. This little device at full speed, which uses only 4.2 volts, can push air at a speed of 11 meters per second, and when converted into miles per hour, that's 24.5 miles per hour worth of air from something that's about bigger than 2 inches, I want to say. I feel like that's about 2 inches. Actually, you know what? Let me grab my caliper. I could use the big boy words instead of a guesstimate. Do. So, that's 42 millimeters, or 1.6 inches. Dinosaur roar, yes, exactly. Now, as I had mentioned, I was playing with this, but I also wasn't doing anything with code, because you're gonna get to see why. Do I have that in frame? I do not have that in frame. All right, let me scoot over here, and we turn and turn and turn and turn. Where am I at here? Oh, we're kind of out of focus. What if I go down a little bit? There we go. Okay, we're in focus. Okay, this was my really sad attempt of putting one of those connectors on. As you'll notice, I've got the leads from my power supply hooked up and not using the breadboard because I screwed up the connector in fantastic fashion. So what we have here is we have the power coming directly from the power supply going through a 1 kilo ohm resistor into the yellow wire. Now, I don't know just yet if this is safe to directly connect to the Arduino, which is what we're going to determine tonight. The Arduino is capable of putting out, I believe it's 20 milliamps worth of power before it's no longer considered safe, and you will burn up the microcontroller. So I need to verify with my multimeter if we have a low enough amperage to connect that yellow pin, the yellow wire, directly to our microcontroller to control the speed of this fan. So what I'm going to do now is I'm going to turn on the power supply, and I can't show you the readings on it because it's not set up in a easy to read manner. Howdy, Dretron, welcome on in. But what I will be able to tell you is the voltages, and then I'll show you with the tissue paper I have here that has some holes in it, what it looks like. Now, I don't know if the noise canceling is going to be able to kill the sound of the fan or not. I'm using my mic pack right now, so I know I've got active noise canceling. You guys will be able to tell me if you can hear it or not, because the thing at full speed puts out 85 decibels of sound. It kind of sounds like a vacuum cleaner. And it's a vacuum cleaner sounding device that, fits in the palm of your hand. So first things first, I'm going to plug in the power supply, because I did unplug this earlier. Let's stick this back into power. So this little guy uses a maximum of 1.5 amps at 4.2 volts. Not a lot of voltage, surprisingly not a ton of amperage. But I can tell you that 1.2 amps would straight up kill. He's a very noisy little thing. It would very much kill the microcontroller because it's infinitely more amperage than it's capable of handling, which is why when we do want to control this with the microcontroller, these two leads are never going to be directly responsible for supplying the amperage. That has to go through the power supply. So I'm going to turn on the power supply, and I'm going to jump out of my skin a little bit there because I saw 11 for a hot second. Oh, it was calibrating. Oh, that scared me. Ooh. Okay, good. So what I can tell you is that with this particular resistor, between the power and the PWM line, that we will see nothing happen until we reach 2.5 volts DC. And then the fan will start to engage. So I'm going to slowly start to turn the voltage up on this. 2.2, 2.4, 2.5. Yep. Okay, so it's currently making a decent amount of noise right now, but it's going to be much louder. Now looking at my microphone. Huh. Interesting. I don't really see it picking up. I'm convinced you're going to be able to hear it though. So that's at 2.5 volts. I'm going to increase it. We're now at 3 volts. And that's pulling 1.1 amp. Up we go. That's 4 volts on the nose, and I'm using exactly 1.5 amps. It's making a ton of noise, and I can confirm that if you let it get close enough, it's trying to pull that in. But on the, well, hang on, I'll have to pull this back a little bit so I can show you. I'm gonna just bring the paper in there. And it's trying to blow it out of my hand. So this is very much no joke. Let me see if I can aim this down a little bit better here. And this is why we use the clamps. There you go. Unfortunately, this is kind of one of those things that you can see it, but it's kind of hard to showcase it. But I can confirm to you, it is kind of noisy, but it's also very powerful for the amount of space this little dude takes up. You can kind of hear it. Yeah, I'd have to turn off my noise canceling, but I can confirm you, it just sounds like a small vacuum cleaner, just kind of doing its thing. So I'm going to turn this back down in voltage, and then it's going to progressively get quieter, and then as we get lower in voltage, right there, 1.7 volts is it just shut off, which is interesting. You know, I changed the orientation. I had this up and down yesterday, and this is facing, it's facing sideways. Let me see here if I can carefully change the orientation a little bit. Point you more up and down, like so. Oh, there. All right, let's roll back up here. He wants to send it flying. And it got caught in the intake again. So yeah, you gotta be a little careful of, you know, what's downstream there. Because it very much wants to just send it flying. Yeah. Alright, I'm gonna turn that off for my own safety. And then, what I want to see, with this still hooked up, before I touch anything, I'm going to pull up the multimeter, and we're going to check to see if this is pulling more than what would be considered safe to hook up to the Arduino. So I'm going to switch this over to the amperage mode, and we're going to set it for the 200 milliamp mode, I believe is where I'm going to want to be here. So I'm going to move that over there. Set that down right there. And what we're going to do is I'm going to hook some wires up to this, and we're going to see how much power the yellow wire will put through the meter. This is an easy way to confirm. I'm on the fuse side of this meter. This is an easy way to confirm of whether this would be safe to hook up to the microcontroller without risking damaging it, because we can get an answer as to whether that is a smart thing to do or not. We have two leads. We have the black and the red. Since we're doing a current check, it doesn't really matter which lead goes where in the regards of the circuit, because I'm wedging it between the red wire and the yellow one, and then we'll see how much amperage we get on here. So let me scoot the camera in so you guys get a better look at that display, because it is a little hard to see. All right, there we go. Good. So the next thing that's going to happen here is I'm going to remove the resistor and the red line from being directly connected. I had the power supply turned off right now, by the way, so there is no power to anything. I'm then going to hook up, I'm going to leave the motor directly connected, and then I'm going to carefully, I'll tell you right now, this helping hand is really great to help me position this stuff. Okay, so you can't see it, it's off camera right now, but I've got this lead by itself, and I'm going to touch it to the resistor with the power supply turned on. I'll hydrate from a sip. I didn't see the rain that came in. Hi, everybody. Oh, no. Hang on. Hold up. Back up the school bus. Please hold.
Wow. I lost my tracking too. Oh, that's rude. Hello, I'm over here. Thank you. I was incredibly focused, and hi everybody. Okay, please, let's see if I can do the thing here. Blah 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 blah. My mouse is in the way. There we go. Excellent. All right, I want to know. Right now, what were you guys doing over there with Dragonus, who is a sweet bean? Thank you very much for the raid. For those of you who are new here, I am TechHead41. I talk about technology. I play retro games. I'm currently trying to build a Protogen Head. This is actively killing me, but in a good way. What were we doing? We were doing art, games. What were we doing in Dragonus' space? I'm curious. All right. While you give me a reply, VRC. Oh, that's good. Good time right there. We're gonna see if this is safe for me to hook up to this little board or not. So I got my spare lead, and I'm gonna see what happens here. So I'm gonna turn the power supply back on. And it's currently got no control line connected, so I'm going to set this back up to 4 volts. Carefully. Okay, so I'm at 4 volts. I got the negative, the positive connected, but there's no power going to the yellow wire. This is why when you have a 3-lead fan, that PWM line can't be left hanging, because the fan's not spinning right now.
VR chat. Very nice, very nice. We love VR chat. That's a good time. So I've got the digital multimeter in DC mode, and I've got this set to hopefully milliamp. And we're going to run the power from the power supply through the meter into the yellow wire using this probe. And then we're going to see what kind of reading we get here, and hopefully sparks. Because, you know, we're living. We're living. We're trying. I'm not supplying enough force here. Hang on, I gotta get my hand on here. 0.9. All right. Okay, so the next thing I want to see if I take this resistor out of the circuit. So I've removed our little friend here. I want to see how high this number goes, because if it's not that much of a milliamperage draw, this should be safe to just connect directly to the microcontroller without risk of damaging. I'm gonna lurk so I can get a certain point in my game to get off the computer for the night, basically. Well, that's all mighty fine, Sasha. Glad to see you hopping on in here with everybody else. Always appreciate you being wandering about. By all means, enjoy. Go do the thing. And I'm gonna try not to blow myself up in the meantime. Okay, as I had mentioned earlier, I mentioned that it didn't matter. Technically, we would want to flow with electricity, so we can ignore the fact that that's negative. But we are so low, I'm going to set this to 10 on here. And in the interest of not having to switch these on the other side, I'm just going to reverse them on here, which is just going to... it won't cause any damage, but it'll make this a positive number because I have them hooked up backwards. I say that as nothing occurs. Did I knock something loose? There's no way that makes a difference. Does it? Shouldn't make a difference. Huh. Well, that's not good. I wonder if I might have killed this without the resistor in here. Either that or it's just making bad electrical connection. Because I didn't think I was doing anything too terribly bad. Is this just loose? I may have killed it. Alright, well, let me hook it back up the way I had it before and see if we spring back to life here, and if not, I've killed it. Okay, so as I saw there, we had very little on the multimeter, and the thing about this is that in the data sheet for this particular motor, it did not indicate any kind of pull-up resistor that was required to make it work safely. So, in the interest here of trying to get this going again, the control board isn't hot. If I had fried something, I would think that you hear it trying. Now the other thing too is it mentioned that you cannot reverse condition these. But all I did was I just switched the leads that were connecting so that we would see a positive number. I did switch the multimeter. I wonder if that might have damaged it. Huh. Yeah, it's reading a very small amount of amperage. Like you hear it clicking. Yeah, a little. So the thing about this is that since these are brushless, the way these know how to spin is by the pulse that this board sends. That's why there's this board protruding out of the back of the fan. It tells it when to start and stop the direct current to make this go. And it got, as you saw, it was going pretty good before I effectively got it to stop working. Okay. False alarm. I didn't actually kill it. I just had the ground was loose there. Okay, so I still need my answer though on whether it is safe to run this without that on there. Am I hedging my bets and potentially frying a $14 motor? Maybe. But I would rather fry one motor than one motor and one microcontroller. Okay, so I'm gonna remove that back out of there. And then I'm gonna put a friendly neighborhood probe in here. Pop that there. And then we should be able to hopefully get a reading then on that. Let's set the 10. Strange. Now I did get it spin when I was on. Interesting. So the internal resistance of the multimeter set to 10. Oh, you know what? I'm going the wrong way. I bet you I'm going the wrong way with this. Yep, that's exactly what it is. I read this backwards. So that is supposed to be 20 milliamp, 200 milliamp, and 10 amp is what that last setting is. So there's so much internal resistance that it wouldn't even spin. Okay, so that is through the resistor. Now I'm gonna take that out. I wanna see how high this goes up to. So we should be able to just do one of these. And we are seeing 0.8. That's not even full speed. Hold up. And we're going to bump it back up to 4 volts. Come on. 4 volts. Oh, not 4.2. 4 volts. There we are. All right, here we go. Oh yeah, we're screaming now. We're reading 0.9, 0.91, 0.92. Now, if I put that back through the resistor, how much does that drop down to? I have to double check the data sheet. I think we're probably a little too close to the maximum current that you can put on one of these pins. I do not want to burn up a microcontroller because I don't have an extra one right now. Yeah, same values. Arguably a little higher. 0.94. Alright. Well, that leaves us into a position where I'm going to need to do a little bit additional research then before we can start directly interacting with the fan. Because I was planning on, as long as it was safe, to hook up that fan to the microcontroller that I have that's spare over here from the 30 Days in Space franchise. This is it's branded as a Hero board, but this is an Arduino Uno. It's just rebranded for the kit. And I don't really want to fry it because that's a part of our development kit we've been playing with. So what that is going to mean is that is really the extent of what we'll do with the fan for tonight. And we're going to pivot to a game. We're going to go back to Maniac Mansion. And then we'll get a little bit of side-scrolling fun in here this evening. For those of you who do not know the game, it is an old-school game that bad ground strikes again. Yeah, you better believe it. Oh, I should turn off the power supply. That'd probably be a good idea. Yoink. Alright, excellent. So that's the trouble with troubleshooting circuits with like these alligator clips. They're really handy for quick and dirty work, as you can clearly see. Sometimes they can cause trouble. Yeah, there's our fan, and like I said, like it's just so small. For the amount of air it pushes out, it's kind of nuts. Alright, so with that, I'm going to move this out of the way. Okay, and then let me get our game booted up here. We'll do a little pivoting. Okay.
I love how every time I turn on this laptop for stream, it has to do Windows updates. And I laugh because every time I turn this on ahead of time so that I won't have Windows updates, and then I proceed to have Windows updates. You want to see a jump scare? We're rebooting. Oh no! Whatever shall we do? Nothing, because we don't need that anymore.